Okay, but Assalamualaikum. So, after completing everything about the filling of electrons in an atom, like the concept of the shell, the concept of subshell, atomic orbital, let's move towards the removal of an electron. So, the first concept about the removal of an electron is basically the concept of ionization energy. Okay, so the basic, like the complete name of this ionization energy is called as standard enthalpy change of ionization or the standard enthalpy change of first ionization. Okay. So whenever they ask you about the ionization energy is exactly the same as the standard enthalpy change of first ionization. The symbol for its enthalpy change, you're familiar from your O levels, is basically delta H. Okay. So this is delta H and ionization is I. And for a standard condition, we use this sign here. Okay. So make sure that you know that this is the sign of a standard condition. Okay, this is a sign of a standard condition. And what does the standard conditions are? Basically, temperature is 298 Kelvin and pressure is 1 atmosphere or 101 kilopascal. Okay, so you know the sign, you know the meaning of this term is standard. Now, enthalpy change is basically the energy change which is associated. Okay, so whenever they ask you about the standard enthalpy change of ionization, is the same thing as the standard enthalpy change of first ionization. To start with the concept, if I write down sodium and if I write down the equation for the removal of an electron from sodium, so after the removal of one electron, it will become 1 plus. Okay, so the energy required to remove this one electron is basically called the first ionization energy. Okay, so the energy required for the removal of the first, which is the outermost electron, is called the first ionization energy. Okay, so this is called first ionization energy. Okay, and make sure that you know that the first ionization energy or any ionization energy value is basically an endothermic value. Okay, so the ionization energy is always endothermic because energy is always required to remove an electron. Okay, हमेशा energy required होती है for the removal of an electron. So delta H ionization is always positive. Okay, clear? Now, the most important thing is that for the removal of, of an electron from the outermost shell, it is very important that your atom must be in a gas form. It is not possible to remove electron when your atom is in a solid form or when your atom is in a diatomic form like Cl2, O2. It is not possible because when you provide energy or when you heat any solid, the first change that takes place is basically the conversion of solid from solid to liquid. It is not possible that you keep any solid in a solid form when you provide energy. Okay, उसमें सबसे पहले state change होना है. And after this state change, it become liquid, and from if you further heat liquid, it will evaporate and it become gas. Now, when your atom is in a gas form and you further provide energy, then it will remove one electron and form a gaseous ion. Okay, so the first process, which is sodium solid to liquid, this is basically called melting. This is not ionization. Okay, this is basically melting, and this is evaporation. Clear? And this is called basically the ionization energy value. So for any equation of ionization energy, although it is for any metal like sodium, magnesium, it is for any non-metal. On the left-hand side, you must have gaseous atom. Okay? You must have gaseous atom. On the right-hand side, you must have gaseous ion. So physical state, याद रखिएगा, ionization energy में is always gas. Clear? So this is the equation for the ionization energy. Now, on the basis of this equation, I can write down the basic definition of ionization energy. So let's write down the definition of ionization energy. The energy required to remove energy required to remove one, instead of writing one electron, I'm going to write 1 mole of electron from 1 mole of gaseous atom, you have to write down the physical state, okay? To form 1 mole of gaseous plus 1 ion, okay? And as we use a standard condition, तो आखिर में आप लिख देंगे under standard conditions. ठीक है बेटा, so this is the definition of ionization energy. The same is the definition of first ionization energy. ठीक है? Sorry, let's do it again. So this is basically the definition of ionization and the definition of first ionization. They will ask you about the definition of a standard enthalpy change of first ionization is going to be the same. Enthalpy change of first ionization energy. Okay, and the symbol for the first ionization energy is going to be delta H with a standard sign I1. Okay, this is a sign of first ionization energy. I hope this is clear. As an example, if I ask you to write down the equation for the first ionization energy of magnesium, so you should write 1 mole of magnesium in a gas form forming 1 mole of magnesium 2 plus, sorry, magnesium 1 plus in a gas form plus 1 electron. Although magnesium always making 2 plus sign, but in this case, we are talking about only the first ionization energy of magnesium. ठीक है, फर्स्ट आयनाइजेशन एनर्जी यानी रिमूवल ऑफ फर्स्ट इलेक्ट्रॉन की बात हो रही है. इफ आई आस्क यू to write down the equation for the first ionization energy of chlorine, so you should write one atom of chlorine, not the molecule, atom, Cl only, ठीक है, forming Cl plus 1 in a gas form plus 1 electron. This is basically the delta H I1 for Cl gas. Okay, I hope the point is clear. So now you can write down the equation of the ionization energy of any metal, any non-metal. Yes, it is true that normally chlorine is always making a Cl1 minus sign, but that's basically the normal ion of chlorine when chlorine reacts with any metal. By force or by providing an energy, you can remove electron from any metal or from any non-metal. आप दोनों से electron remove कर सकते हैं. Yes, the only difference is the energy required to remove electron from metal is less and the energy required to remove from non-metal is more. That's why normally non-metal making a negative ion, they do not release electron, they gain electron. ठीक है? So यहाँ हम note down कर लेते हैं the energy required to remove electron from a non-metal is larger than a metal. Okay, that's why normally non-metal form a negative ion and do not release electron. Okay, so this is basically the concept of ionization and basically the first ionization. Key point क्या है कि gaseous atom होना चाहिए, 1 mole होना चाहिए, 1 electron remove होगा. But as you know that if we talk about magnesium, normally magnesium form a Mg2 plus ion. Okay, Mg2 plus ion. So if I remove one more electron from 1 plus to make it 2 plus, if I remove one more electron of magnesium 1 plus ion to make it 2 plus, यानी दो इलेक्ट्रॉन रिमूव करने हैं तो 1 by 1 करेंगे. पहले आप फर्स्ट आयनाइजेशन एनर्जी प्रोवाइड करेंगे, it become 1 plus, then you provide the second ionization energy value and it become 2 plus. So the next definition is basically a standard enthalpy change of second ionization energy. ठीक है बेटा, standard enthalpy change of second ionization energy, and we represented it by delta H standard I2. Okay, second ionization energy is I2. And just clear this one, +1. Okay, I'm just going to write it down here again. So this is the equation, standard enthalpy change of, okay, I'm going to write down the equation here. So second ionization energy is from 1 plus to 2 plus. स्टैंडर्ड फिजिकल स्टेट आयनाइजेशन एनर्जी में सारी गैसेस होती हैं, ठीक है, क्लियर. सो एज पर दिस कैन आई से दैट द एनर्जी रिक्वायर्ड to remove 1 mole of electron from 1 mole of gaseous plus 1 ion to make 1 mole of gaseous plus 2 ion. Okay, and this ion, sorry, and this must be under a standard condition. Okay, beta. So the above equation represent the second ionization energy of मैग्नीशियम. ओके, तो सेकेंड आयनाइजेशन एनर्जी में आपने क्या करना है, 1 प्लस से इसको लेके चले जाना है 2 प्लस में. इजी, क्लियर. सो इफ आई आस्क यू टू राइट डाउन द इक्वेशन फॉर द सेकेंड आयनाइजेशन एनर्जी व्हिच इज डेल्टा H I2 फॉर Al1 प्लस गैस. ठीक है, इस नोटेशन में यहां पर हमेशा रिएक्टेंट आता है. सो एल्युमिनियम की सेकेंड आयनाइजेशन एनर्जी की इक्वेशन आपसे पूछी जा रही है. सो यू कैन इजिली राइट, ओके, इट इज Al1 plus gas forming Al2 plus gas plus 1 electron. Okay, so in any case, magnesium ho, aluminum ho, it could be chlorine, it could be oxygen. Whenever they ask you about the value for the second equation for the second ionization, it's always 1 plus say 2 plus, and all the physical state are gas. ठीक है, delta H I2 यानी second ionization energy value is always greater than delta H I1. Why? Because इसका रीजन क्या होगा बेटा, रीजन ये होगा कि after the removal of electron, after the removal of one electron, there are more proton, less electron. Let's talk about sodium. 11 neutral, it has 11 proton and 11 electron. You remove one electron, make it Na positive. Okay, Na positive have 11 proton and 10 electrons. Okay, so the removal of electron is difficult from Na positive because it has more proton and less electron. So the force of attraction of the nucleus on the remaining electron increases. वो ज्यादा strongly attach हो जाएंगे, उनको remove करना ज्यादा मुश्किल होगा. ठीक है, delta Hi2 second ionization energy is greater than delta H I1, as after the removal of one electron, there are more protons and less electrons. And less electrons. So, force of attraction of nucleus increases. ठीक है, when the force of attraction of nucleus increases on the remaining electron, this is basically called the effective nuclear charge. Effective means proton उतने ही हैं, but faced by the electron is more. Electron ज़्यादा face कर रहा है. ठीक है, so this is basically in a similar way the third ionization energy value even greater than second one. Okay, and the fourth is even greater than the third one. Okay, now keeping this one in mind, let's talk about the successive ionization energy value. Successive ionization energy values. Basically, this there's no definition of successive ionization energy value. It's basically a concept that if you have sodium, proton number 11, it has how many electron? 11 electron. So the sodium should have 11 ionization energy values. 11 ionization energy values. And if I give you the data of these 11 ionization energy value, this data is called the successive ionization energy value. Okay? So can I say that successive ionization energy is basically the data or the sequence of energies required for the removal of one by one all the electrons until only the nucleus is left. लिख लेते हैं. Successive ionization energy is basically the sequence of ionization energy is required to remove one by one all the electrons until only nucleus is left. Okay, so if you have magnesium, there are like 12 ionization energy value because it has altogether 12 electron. Aluminum के लिए 13 होंगी, ठीक है. But last thing, successive ionization energy value increases. Successive ionization energy value increases after the removal of every electron. And reason वही है, there is more protons and less electrons. ठीक है, the removal of every electron. ठीक है बेटा. So this is basically the idea and the concept of ionization energy. Before I wind up, if I ask you that this equation, which ionization energy value is represented by this equation? Is it the first ionization energy value or is it the second? फर्स्ट में तो 0 से 1 प्लस में जाता है, सेकंड में 1 प्लस से 2 प्लस में जाता है. ओके, इस इक्वेशन में 0 से 2 प्लस में जा रहा है. एंड इफ आई आस्क यू कि इस हाउ मच एनर्जी इज रिक्वायर्ड और व्हाट इज द एंथैल्पी चेंज, तो आप बोलेंगे बेटा दिस इज डेल्टा एच आई वन फर्स्ट आयनाइजेशन प्लस सेकेंड आयनाइजेशन एनर्जी. ठीक है, ये दोनों का सम है. दिस इज द सम ऑफ फर्स्ट आयनाइजेशन प्लस सेकेंड ऑफ. In short, if I ask you how much energy is required for this process, तो आप बोलेंगे पहले आप फर्स्ट आयनाइजेशन एनर्जी प्रोवाइड कीजिए एंड सेकंड, लेट्स से the first ionization energy is 496 kilojoules, the second one is 1450. If you provide the total all together, then simultaneously आपके पास दोनों इलेक्ट्रॉन रिमूव हो जाएंगे. ठीक है, so if they give you any equation like this, you should know that this is not the first one, this is not the second ionization energy, this is the first and the second ionization energy value. I hope the point is clear. So this is basically the quick concept of about the definitions of ionization energy. You should know the definition of first ionization, second ionization. Most important, you should know how to write down the equations for the first and the second ionization energy. The concept that the second ionization energy value is always greater than the first one. Okay? And then successive ionization energy value, the data, normally the data is given for more than one ionization energies. This is called a successive ionization energy data. And the value of successive ionization energy increases after the removal of every electron. Okay. So next is basically the factor affecting ionization energy value, which we're going to do it in the next class.